what is here I have understood a case for theta is equal to 90 degree. What is the radius of the charged particle in uniform magnetic field? What is the time period of the charged particle in uniform magnetic field? What is the frequency? What is the angular frequency? Okay, these formulas should be noted, very very important. Okay, tell me all of you, what is the radius of the charged particle, radius of the circle? Okay, when the charged particle is moving perpendicular to the magnetic field, what is the formula? mv by bq or mv by qb. Okay, here radius of the circle is directly proportional to the speed of the particle, charged particle. And what is the time period? Time period is what here? 2 pi m by bq. And frequency how much here? bq by 2 pi m. Angular frequency is how much here? bq by m. Okay, this principle again we are going to use in where? Cyclotron. Very very important. Why? Because this time period, frequency, angular frequency does not depend upon speed of the charged particle for given mass of the particle and okay, in given magnetic field and given charged particle. Okay, this omega t f does not depend upon the speed of the particle. Okay, in time period expression we are not seeing the speed. In frequency we are not seeing seeing speed, and omega also okay v is not there. Means time period, frequency, angular frequency does not depend upon the speed of the speed of the particle, charged particle. Okay, I hope you understand this one. Next, case 3. Theta is equal, okay, other than 0 degree, 90 degree, 180 degree, means theta is equal to, okay, so maybe 10 degree or 20 degree or 30 degree, 40 degree, means other than 0 degree, 90 degree, 180 degree. In that case, what is the path? Helical. Already we understood. Okay, by so this velocity, angle between the velocity and magnetic field, how much it is there? Theta. This velocity has how many components? 2 components. Along the magnetic field, component of velocity is what? V cos theta. Okay, so perpendicular to the magnetic field, what is the component? V sin theta. V cos theta makes how charged particle move along the straight line path. V sin theta components makes what? The charged particle move circular. Correct? Na? So then we want radius, for expression for radius. Okay, so what is the radius here? What is the radius? How to calculate radius here? So how to calculate radius here? Radius of the charged particle. So how to calculate the radius of the charged particle? The radius of the charged particle. Okay. So this is what a radius. This is what a radius. How to calculate that radius? Okay. For circular path, which component is required? Okay. So V sin theta or V cos theta. For circular path, which component is perpendicular to magnetic field? That component is makes the charged particle move along the circular path. With that component, we will get the what? Radius. Okay, na? So in this case, what happened? This is a radius. So in this, which component is V sin theta component? Okay, V sin theta. V sin theta. V sin theta. By using V sin theta, what happened? The charged particle is makes circular path, move along the circular path. V cos theta along the straight line path. Okay, now in that circular path, so centripetal force is balanced by which one? Again magnetic force. Again Fc is equal, what you should write? Fm. Fc is centripetal force. Circular path compulsory which force should be takes place there? Centripetal force. This centripetal force is balanced by whom? So magnetic force. What is the Fc here? Fc is mv perpendicular square by r. What is this perpendicular? Due to this perpendicular component only, circular path, the particle is moving along the circular path. mv perpendicular square by r is equal to, okay, what is Fm here? Fm is a magnetic force. What is the magnetic force here? Q V B sin theta. So theta how much here? 90 degrees. Theta how much here? 90 degrees. So so what is the velocity component here? Velocity component is what? V perpendicular. Q V perpendicular V. Correct na? Right. So 1 V perpendicular cancel. Then R you bring this side. You will get R is equal to radius of the charged particle in helical motion. R is equal to m V perpendicular by VQ. Okay. Then R is equal to what you will get? M V perpendicular is what? V sin theta. Correct? Na? mv sin theta by VQ. Very important. Theta changes, radius of the helical motion also changes. Okay. Again, expression for radius of the charged particle in this case, what happened? Theta is not equal to 0, theta is not equal to 90, theta is not equal to 180. Due to which component the particle is in circular path? That component of velocity you have to take. Okay. Circular path means compulsory there is a centripetal force. Okay, the centripetal force by whom which came it is a magnetic field. Okay, magnetic field. This is a magnetic field due to magnetic field. Okay, so magnetic force and centripetal force. Centripetal force is mv perpendicular square by r. Okay, due to this component v perpendicular. That is equal to q vb. Okay, v perpendicular b, and this v sin theta, how it is with the b perpendicular. Q v perpendicular b sin 90. Correct na? Q v perpendicular b perpendicular cancel. Then r is equal to this, r bring this side, qb you bring this side, and r is equal to mv perpendicular by bq. R is equal to what? Mv sin theta by bq. This is a radius of the charged particle in a helical motion. Very important, that one. The next expression for time period, frequency, angular frequency. Time period. What is the time period? So t is equal circular path. For circular path, you should choose which component? Perpendicular component. For straight line path, you should choose which component of velocity? V cos theta. Now we are calculating time period, radius, angular frequency. They all belongs to which one? Circular motion. Nothing but you should take which component? Velocity component means perpendicular component you have to take care. Then time period. What is the time period? 2 pi r by, so 2 pi r by speed. Speed is what? V perpendicular. What is that? Perpendicular. V perpendicular. Then so 2 pi r is what here? So V perpendicular. So r is what here? MV perpendicular by BQ. Already we understood. R is equal to MV perpendicular by BQ. So V perpendicular cancel. Then we got how much here? 2 pi m by BQ. 2 pi m by BQ. That is the time period of the charged particle. Okay, here also we got it. T is equal to 2 pi m by BQ. Here also T is equal to 2 pi m by BQ. The charged particle is moving in uniform magnetic field, whether it's a circular motion or helical motion. What is the time period of the charged particle? 2 pi m by BQ. Time taken for one complete revolution, how much? 2 pi m by BQ. It is not just, time period does not depend upon the speed, does not depend upon the theta. Okay na? So here circular path, it is moving nothing but time period is so 2 pi m by BQ. In circular motion or helical motion, time period is what? 2 pi m by BQ. Then frequency same thing, BQ by 2 pi m. Correct na? So angular frequency, BQ by m, same thing. Okay na? I hope understood. What is the frequency, students? Frequency reciprocal of time period, BQ by 2 pi m. What is the angular frequency? 2 pi you remove. In frequency you remove 2 pi. You will get what? BQ by m. Okay, angular frequency is what? BQ by m. Next what? Pitch. Very important, pitch. What is the pitch? Okay, that is a pitch is a successive distance between two helical threads. This is one helical thread. This is one helical thread. Okay na? So this is one helical thread. This is one helical thread. Successive distance between two helical threads. Okay. So distance, horizontal distance traveled by the particle for one complete circular path. That is called as what? Pitch. Okay. This is called as pitch or helix. Pitch or helix. How to calculate this pitch or helix? Pitch or helix is equal to, pitch is nothing but distance. Okay. Horizontal distance traveled by the particle for one complete circle is called as what? Pitch or helix. Okay. Or successive distance between two helical threads is called as what? Pitch. That pitch is equal to which component of velocity here? Parallel component of velocity. Okay. Along the direction of magnetic field, so speed. Into what? So speed is equal to distance by time. Distance equals speed in time. So V perpendicular into, okay, one complete revolution of a circle. How much? That is the time period. V parallel into time period. What is the V parallel here? So V parallel is V cos theta. So along the direction of magnetic field, along the straight line. Which component is acting here? V cos theta. Into time period is what here? 2 pi m by BQ. 2 pi m by BQ. Then what is the pitch? Here pitch is what? So 2 pi m V cos theta. So pitch is what here? 2 pi. Pitch is what here? 2 pi m V cos theta by BQ. 2 pi m V cos theta by BQ. Very important. Pitch is what? 2 pi m V cos theta by BQ. Correct now? I hope you understood. So pitch is nothing but, so along the horizontal, along the direction of magnetic field, okay, what is the velocity? That is the V cos theta into time period. Distance is, pitch or helix is nothing but distance. What is the distance? Speed into time. That speed is what? Along the direction of magnetic field, which is speed? V cos theta. What is the speed component? V cos theta. Into time period is what? 2 pi m by BQ. Then that is a pitch is a 2 pi m V cos theta by BQ. Very important. So they will give the theta with okay, and mass of the charged particle, velocity of charged particle, BQ. They'll what that they are going to find. They are going to ask what? So pitch of the particle. Okay. I hope you understood this one. Motion of charged particle in magnetic field. Okay, for different angles, how it will be, and what is the radius of the charged particle, what is the frequency, what is the time period. Okay, I hope understood. Correct na? In case of this is very important, right? In helical motion case, don't confuse. Okay, in helical motion case, the particle is moving not perpendicular, not parallel, not anti-parallel, means it is moving with some angle theta. So in that case, it has two components. Along the direction of magnetic field V cos theta, perpendicular to magnetic field V sin theta. So V sin theta components makes the charged particle move along the circular path. V cos theta components, the charged particle move along the straight line path. It is a combination of what? Straight line motion and circular motion. That's why this is called as a helical motion. Okay, so due to which component of velocity the particle in circular motion? V sin theta. That's why, so mv perpendicular, v perpendicular, mv square by r. So which v here? So circular, for circular motion, perpendicular velocity we taken. Magnetic force what? qv perpendicular b. V perpendicular, v perpendicular cancel. Then r is equal to mv perpendicular by vq. V perpendicular is nothing but v sin theta. R is equal to mv sin theta by vq. Next is time period already. Okay, same way we calculate time period here. So in this case time period. Okay, for calculation of time period, for calculation of radius, for calculation of frequency, for calculation of angular frequency, we can use which component? V sin theta component we can use. T is equal to 2 pi r by V perpendicular. Okay na? So due to this component only, the particle is moving along the circular path. Then 2 pi by V perpendicular into R. R is, in this case, R is what? mv perpendicular by vq. V perpendicular cancel. Then you get 2 pi m by vq. Then pitch is what here? So speed into time. Okay, pitch is nothing but horizontal distance covered by the particle for complete circular path. Is called as what? Pitch or helix, or successive distance between two helical threads in helical motion is called as what? Pitch. That speed into time. Okay, parallel component of okay, or horizontal component of speed. That is what, along the direction of magnetic field, what is the speed? V cos theta into time period. Time period is what? 2 pi m by vq. Simplify, you will get what? So pitch is equal to 2 pi m v cos theta by vq. Okay, students. So we are going to understand now. We understood the concept of what? The motion of charged particle in uniform magnetic field. Okay, so I'm taking one textbook example. This is a 4.3, right? So 4.1, 4.2. You take homework from your textbook. 4.1, 4.2. You take homework from your textbook. If you don't have textbook, you can download from Google. You'll get it. You take homework example. Okay, 4.1, 4.2. Take homework. 4.3 I'm discussing now. Okay, so understand, for understanding the concept, I take this example. See, what is the radius of the path of an electron? Okay, mass given. So mass of the particle given. How much given mass of the particle? 9 into 10 power minus 31 kg. Okay, and the charge how much given here? Charge of the particle E is equal to Q is equal to how much given here? 1.6 into 10 power minus 19 coulomb. And moving at a speed of how much given V? V is here 3 into 10 power 7 meter per second. And the magnetic field how much given? So B is equal to 6 into 10 power minus 4 Tesla. Okay, perpendicular to it means what? Theta is equal to 90 degree. Means how the particle is moving? The charged particle is moving perpendicular to the magnetic field. Okay, what is its frequency? Okay, then first which one asking? Radius first. Then you calculate radius. Then what is asking? Frequency. Okay, so after that which value asking? Kinetic energy, K value asking. First we can calculate what? Radius. We know the formula. What is the formula of radius of the particle? Radius of the charged particle in any form magnetic field. Okay, with the charged particle is moving perpendicular to the magnetic field. What is the radius? R is equal to mv by vq. We know this formula, correct na? So very important. R is equal to mv by vq. Just substitute the values here. Mass of the particle how much here? 9 into 10 power minus 31. Speed how much? Speed 3 into 10 power 7. And by vq. So magnetic field how much? 6 into 10 power minus 4. So charge 1.6 into 10 power minus 19. Okay. This you can simplify. You will get the answer 26 into 10 power minus 2 meter. Okay, simplify it. You will get 26 into 10 power minus 2 meter. 10 power minus 2 meter. That is equal to 26 centimeter. Okay, in board exam, they'll ask for 5 marks this type of question, or they'll ask for 3 marks. Okay, the radius we calculated. So radius how much we got? 26 centimeter. MV by BQ. M given, so V given, B given, Q given. If you know the formula, easily we can calculate what the radius of the charged particle in a magnetic field. How much radius here? 26 centimeter. I hope you understood. Correct na? R is equal to MV by BQ. We substitute values. Then we got a 26 centimeter. Next what? Frequency. Okay. So frequency, you know the formula. What is the frequency formula? QB by 2 pi. Correct na? T is equal to 2 pi m by QB. F is equal to QB by 2 pi m. Just now we understood. Correct na? F is nothing but frequency of charged particle in a uniform magnetic field. F is equal to QB by 2 pi m. So Q is what here? Charge. Charge how much given? 1.6 into 10 power minus 19. B how much given here? Magnetic field how much given? 6 into 10 power minus 4 by. So 2 into pi value how much here? 3.14. Mass how much here? 9.1 into 10 power minus 13. Okay, just substitute Q value, B value, and 2 into pi value 3.14, M value 9.1 and 10 power minus 31. If you simplify, and then you will get the answer what here? 2 into 10 power 6. What is that? 2 into 10 power 6 Hertz. Frequency measured in what? Hertz. Okay, so that is what? 2 megahertz you will get. Okay, by using calculator you can simplify. In board exam calculator is allowed. Okay, 1.6 into 6 by 2 into 3.14 into 9.1. Then the powers you simplify, you will get what? 2 megahertz or 2 into 10 power 6 hertz. You will get it. So next what? Kinetic energy. In a kinetic, in a kilo electron volt. What is a kilo electron volt? You can calculate what? Kinetic energy. Okay. So how to calculate that kinetic energy? Kinetic energy means what? K is equal to half mv square. Correct na? So half into what is the mass? Mass is 9.1 into 10 power minus 31. So what is the speed here? Speed is 3 into 10 power 7 meter per second. V square means what? 9 into 10 power 14. So 9 into 10 power 14. So this you will get the in joule. Energy, what is the essence of energy? Joule. So that if you calculate means how much you will get energy? 4 into 10 power minus 16 joules you will get. Correct na? 4 into 10 power minus 16 joules you will get. Half into 9.1 10 power minus 31 into V is what here? 3 in 10 power 7 meter per second. V square means how much here? 9 10 power 14. Simplify means you will get 4 into 10 power minus 16 joule. This joule you convert into what? Kilo electron volt. Good now. So here 1 electron volt. Okay. 1 kilo electron volt will write. 1 kilo electron volt is how much? Kilo means 10 cube. 1 electron volt is how much? 1.6 into 10 power minus 19 joule. 1 kilo electron volt is how much? 1 kilo 10 cube into electron volt means 1.6 into 10 power minus 19. Correct now? Then 1 kilo electron volt is 1.6 into 10 power minus 19 plus 3. How much it is? Minus 16. Minus 16 joule. From this we will get 1 joule is equal to. From this we will get 1 joule is equal to 1 by 1.6 into 10 power minus 16 kilo electron volt. 1 joule is equal to how much? 1 by 1.6 into 10 power minus 6 kilo electron volt. Correct na? Right? Then if you know 1 joule value in kilo electron volt, we know that kinetic energy how much we got? Kinetic energy K is equal to 4 into 10 power minus 16 joules. This you can convert into kilo electron volt. 4 into 10 power minus 16 into 1 joule is equal to how many kilo electron volt? 1 by 1.6 into 10 power minus 16 kilo electron volt. You understood na? 1 kilo electron volt is what? Kilo 10 cube electron volt 1.6 into 10 power minus 19 joule. That is how much? 1.6 into 10 power minus 19 into 10 power 3. How much it is? 10 power minus 16. Okay. Then 1 joule is equal. This value bring this side. 1 joule is equal to how much? 1 by 1.6 into 10 power minus 16 kilo electron volt. Okay. Otherwise remember directly. What is that? 1 joule is equal to 1 by 1.6 into 10 power minus 16 kilo electron volt. Remember directly. 1 joule is how many kilo electron volt? 1 by 1.6 into 10 power minus 16 kilo electron volt. Kinetic energy how much we got? 4 into 10 power minus 16 joules we get. We got it. But in the question, okay, calculate its energy in kilo electron volt. then how much it is? 4 in 10 power minus 16 joule you convert into kilo electron volt. 1 joule is equal to how many kilo electron volt? 1 by 1.6 in 10 power minus 16 kilo electron volt. Okay, you simplify this one, right? 10 power minus 16, 10 power minus 16 cancel, you will get so 2.5. Kindly can you how much you will get? So 4 by 1.6, 40 by 16, 40 by 16 means what? 2.5 kilo electron volt. This is a kinetic energy of the charged particle in that magnetic field. I hope you understood. Radius of the charged particle, frequency, kinetic energy in kilo electron volt. Okay students, thank you.